Hello everyone, my name is Jayanth.C and I am currently pursuing my BE in Sri Venkateshwara College of Engineering, Bengaluru. The course title is Applied Physics for CSE stream and I am currently studying in first semester. The topic which we are going to discuss today is high temperature superconductivity. The content which we are going to discuss today is Introduction to High Temperature Superconductors, High Temperature Superconductors, Classification, Properties, Applications, Advantages and Disadvantages of High Temperature Superconductors. Introduction. What is superconductor? Superconductors are the materials that conduct electricity with zero electrical resistance when cooled below a certain temperature known as critical temperature. This property allows superconductors to carry electrical current without losing energy, making them incredibly efficient for various applications. Superconductivity. Superconductivity is a phenomenon of exactly zero electrical resistance and expulsion of magnetic fields occurring in certain materials when cooled below critical temperature. Like ferromagnetism and atomic spectral lines, superconductivity is a quantum mechanical phenomenon or macroscopic quantum phenomenon. Temperature superconductors. High temperature superconductors represent a new class of materials which bear extraordinary superconducting and magnetic properties and great potential for wide-ranging technological applications, whereas ordinary or metallic superconductors usually have transition temperature of about 30 Kelvin, that is minus 243.2 degrees Celsius, whereas high temperature superconductors have been observed with transition temperatures as high as 138 Kelvin, that is minus 135 degrees Celsius. They are called high temperature superconductors on basis of critical temperature is greater than boiling temperature of liquid nitrogen, that is 77 Kelvin or minus 196 degrees Celsius. The working process of high temperature superconductors involves materials that, when cooled below critical temperature, exhibit zero electrical resistance and expel magnetic fields. Until recently, only certain compounds of copper and oxygen, so-called cuprate, were believed to have high temperature superconducting properties, and the term high temperature superconductor was used interchangeably with cuprate superconductor for compounds such as bismuth strontium calcium copper oxide known as BsCCO and yttrium barium copper oxide YbCO. However, several iron based compounds are now known to be superconducting at high temperature. The recently developed high temperature superconductors are from ceramic compounds. Classification of high temperature superconductors. High temperature superconductors are broadly classified into two types. Type 1. These materials expel magnetic fields efficiently but have a low critical magnetic field strength. They typically cannot withstand strong magnetic fields before losing their superconducting properties. Type 2. Type 2 superconductors, on the other hand, can sustain higher critical magnetic fields. They exhibit a mixed state where some magnetic flux penetrates the material in the form of vortices. These vortices allow type 2 superconductors to maintain their superconducting properties under stronger magnetic fields, making them more suitable for practical applications in various engineering fields. Properties of high temperature superconductors. Critical temperature. Unlike traditional superconductors that require extremely low temperature, that is near absolute zero, high temperature superconductors can achieve superconductivity at relatively high temperatures, although still quite cold compared to the room temperature. They typically operate at temperatures above the boiling point of liquid nitrogen, that is minus 196 degrees Celsius. Complex structures. High temperature superconductors often have complex crystal structures including layers of different elements such as copper oxides or iron based compounds. Flux pinning. These materials have the ability to pin magnetic flux lines, allowing them to maintain their superconducting state in the presence of magnetic fields. This characteristic is crucial for practical applications where magnetic fields are present. Anisotropic properties. High temperature superconductors often exhibit different superconducting properties depending on the direction of current flow or magnetic field orientation. This anisotropic behavior is a unique feature of these materials. Applications of High temperature superconductivity. High temperature superconductors are used in various sectors like power generation, medical imaging, transportation, scientific research tools, energy storage, electronics and sensors or detectors, etc. Advantages and disadvantages of high temperature superconductors. Advantages. First, reduce energy loss. They conduct electricity without resistance, minimizing energy losses during transmission. This property is crucial for efficient power grids and long distance power transmission lines. Second, higher operational temperatures. High temperature superconductors achieve superconductivity at relatively higher temperatures compared to traditional superconductors, enabling easier cooling methods, that is using liquid nitrogen instead of more expensive and complex cryogenic systems. Third, strong magnetic fields. These materials can generate powerful magnetic field lines, making them more valuable for applications like MRI machines in the healthcare and research facilities. Fourth, compact and efficient devices. Superconducting materials enables the creation of smaller and more efficient devices due to their ability to carry high currents without energy loss, leading to compact and potent systems. Fifth, potential for faster electronics. High temperature superconductors could revolutionize electronics by reducing heat in circuits, enabling faster and more efficient computing. Sixth, magnetic levitation. They allow for the development of magnetic levitation transportation systems that are faster, quieter and more energy efficient than traditional transportation method. Disadvantages of high temperature superconductivity. First, temperature requirements. Despite being called high temperature superconductors, they still require extremely cold temperatures, often below -100 degrees Celsius, while this is warmer compared to traditional superconductors. Second, materials and fabrication challenges. The fabrications of high temperature superconductors can be complex, involving intricate structures and compositions. Producing these materials in bulk and ensuring uniformity can be challenging and expensive. Third, limited commercial availability. Mass production of reliable and cost-effective high-temperature superconducting materials remains a hurdle, limiting their widespread adoption in various applications. So this was all about today's topic. Thank you for watching video. Please like, share and subscribe.